In this lesson, we're going to be doing more algebra. We have two objectives. The first 10 problems we're given expressions and we're asked to factor completely. The bottom 4 problems we're given complex fractions and we're asked to simplify. Right? If we're asked to factor completely, the very first thing we do when we factor is we look for what we call a greatest common factor, or a GCF. We'll pull that out first, and then depending upon what's left in the problem, we'll determine how we're going to continue factoring. So let's always try and remember to look for a greatest common factor. So number 1, we want to first of all identify that we have two terms. Terms are what you add or subtract. So here we have a term and here we have a term. Each of the two terms share a common factor of 3, so let's go ahead and pull that GCF out front. So 3 times, and then in parentheses, we'll put in here what we have left when we factor out of 3. Well, 3 comes out of 300, leaving 100, and we still have x squared, and we have minus, and 3 pulls out of itself 1 time. You can always check your factoring by multiplying back in to see if you get to the original problem, and we do. So at this point, before we leave the problem, there may be more work to do. And so when we look at this binomial right here, this is actually a difference of 2 squares. So you might want to think about, what do I square? I'm going to let A be what I square to get the first term, 10x. And what do I square to get B? Or excuse me, what do I square to get 1? And I'm going to call that B. Well, that's just 1. So this difference of 2 squares factors into a sum and difference of like terms. So we're going to do a plus b and a minus b in each of these two binomials. So this will factor into 10x minus 1 and 10x plus 1. And just by inspection, I don't think I can continue to factor in either of these binomials, so I'm done. I've factored completely. Okay, and number 2, we have a trinomial. 3 terms. Terms are what you add or subtract. I have 3 terms. This is called a trinomial. Let's first look for a GCF. Well, x squared, 4x, and 3 don't share any common factors other than 1, so there's no GCF there. So our approach here is to try and break this down into 2 binomials that multiply and give us this trinomial. Because our coefficient on x squared, called a, is 1, we call this a, b is 4, and c is 3. Okay, because a is 1, this should be an easy factor to where I should be able to put an x up front and an x up front to multiply and give me x squared. Now the numbers that go behind here in the binomials, you could do it by trial and error, or if you want to go back to a factor sum chart, I call it factor sum chart. We're going to be looking for factors of AC, so that's 1 times 3, or 3. Factors of AC that sum to B, which is 4. So this is AC and this is B. The best thing to do is to list all the different factors of 3. List the sets of factors of 3. Well, the sets of factors of 3 are 1 and 3. And if I were to add 1 and 3, I would get 4. So these factors right here tell me what's going to go in the binomials. This is going to be x plus 1 and x plus 3. And it doesn't matter if you have x plus 3 up front and x plus 1 behind. It doesn't matter. Neither of these binomials can be factored any further, so we're actually done. Okay, looking at number 3, first thing we want to look for is the GCF in this trinomial. Well, here's my first, second, and third term. Terms are what you add or subtract. I do notice that I can pull a 2 out. So factoring a 2 out is going to give 2 times quantity x squared minus 6x plus 9. Now let our attention focus right here on this trinomial. Again, it's like problem number 2, where now inside this parenthesis, a is 1. So you can try and factor this trinomial by trial and error. Okay, we can see if it factors. Or you can come over here and do your factor sum chart. So remember, factors of AC. So now my new A is 1, and my new C is 9. So factors of 9 that sum to -6. I always start listing my sets of factors with 1. So 1 and 9 multiply and give me 9. 2 doesn't go into 9. 3 does 3 times. Now I can multiply positive 3 by positive 3 and get positive 9, which is good, but I need to be able to sum to a -6. So that tells me I'm going to adjust and make both of these factors negative. I'll still get a positive 9, but when I sum these numbers, I'm going to get -6. And just check your work over here by adding them. And that is -6, so that checks. So that tells us that we can easily slip in here x minus 3 and x minus 3. And we're finished. You may see this written as 2 times quantity x minus 3 squared. They just doubled up there. That's fine too, but it really doesn't matter. Okay, let's look at number 4. First thing, we want to look for a GCF. I don't see a GCF because 8, 10, and 3, they don't share any common factors. This won't be an easy factor because A is 8. A is 8, B is -10, and C is -3. This won't be an easy factor to where I can go straight to 2 binomials like I did up here in number 2. We're actually going to use factor by grouping for 4, 5, and 6. Factor by grouping, you may have learned it as using the box method, and that's fine. If you're comfortable with the box method, you just go right ahead and factor. And as a matter of fact, on 4, 5, and 6, you might want to shut off the video and attempt these on your own, and then come back to see how you did. I'm going to actually do factor by grouping on 4, 5, and 6. So what I'm going to do is I'm going to come over here and do my factor sum chart again. So I need factors of A times C, or -24, that sum to B, or -10. Now I'm going to go down the factor column, and I'm going to ignore the negative sign for a minute, and I'm just going to look for factors of 24. So 1 goes into 24, then I'm going to go up to 2. 2 goes into 24 12 times. 3 is a factor of 24. 4 is a factor of 24. 5 is not. 6 is a factor of 24, but I've already got it listed, so I can stop. Now let me consider the negative sign. I need to multiply these two numbers together and get a -24, which means one of these numbers in any of these sets has to be negative, only one. But I want to choose the set where I make one of the factors negative and I sum those two numbers, I get -10. It looks like if you made 12 negative and you added 2 plus -12, you're going to get the -10 that you want. So that's good there. All right, so what do I do with these factors now if I can't go straight to the 2 binomials? Well, factor by grouping tells us that we keep the first term, 8x squared, but we break the middle term, the linear term, into the sum of 2 other terms that add to -10x. So I'm going to use 2 and -12, and I'm going to rewrite linear terms with them to add to -10x. Now, I could write down plus 2x minus 12x, but I'm going to choose to put the negative term first. So I'm going to take -12x and add 2x. And think about collecting these. They will get you back to the -10x. There's a method for my madness in putting the negative up first, negative term up front first. And I'll share that with you in a minute. So I kept the first term, I broke the middle term up into the sum of 2 other terms created from these factors, and then I bring down the last term. So to continue with factor by grouping, then what we do is we group the first 2 terms. And now I have a plus here as opposed to the -12x. So plus, and then I'm going to put the last 2 terms in parentheses. The reason I didn't put -12x here is because if you have a minus here and you put parentheses around the last 2 terms, you're going to have to change this sign of this last term for it to check and get you back up here. And sometimes we forget to change that sign, so we're trying to avoid an error that might occur. So to continue to factor by grouping, now we look at these 2 sets of parentheses and we look for a GCF. So in this parenthesis, I know 4x is a common factor, so I'll pull out 4x from just this parenthesis. So I'm left with 2x minus 3. Now I'm right here at the plus sign. Well, 2x and 3 don't share a GCF other than 1, and I'll just go ahead and put the 1 up front there. So if this trinomial factors, then I should be able to proceed this way. I should get this same factor right here. If these aren't the same, that's a built-in check process that we made a mistake. So now to continue, think about this being one term and this being my second term. So this term is made up of a bunch of factors, including a parenthesis as one of the factors. Okay, and this is also another term that has a couple of factors. What do they share, these 2 terms? Well, they share that common parenthesis. So I'm going to factor that out as my GCF. I'm going to put it up front. I'm going to put my parenthesis here. When I factor out 2x minus 3 from this term, I'm left with 4x. I'm at the plus sign. When I take out 2x minus 3 from this term, I'm left with that 1 that's up front. I do a final inspection. Can I factor any more within these parentheses? Do they have a GCF? Nope, so I'm finished. Boxing should get you the same answer, okay? All right, 5 and 6, okay? 5, first I look for a GCF. There's not one. So then I go, oh, this might be a factor by grouping. You can always do trial and error to get down here, but it might take you longer to do trial and error than it is to actually go through and factor by grouping or use your box method. All right, so we're looking for factors of -6 that sum to -1. So list the factors of 6. Ignore the negative for the time being. Here we go. Those are the only sets of factors for 6. But we know within each set, one of these numbers has to be negative, and when you add them, you have to get -1. So it looks like 2 plus -3 is going to be the -1 that we need. So we're looking at this set of factors. So factor by grouping, 3x squared. Let's break this middle term up into the sum of these two terms having these coefficients. So I'll put the minus term up front. And then don't forget to bring down the last term. So what's next? Group. And group the last two. Let's look at taking out common factors. So GCF here is 3x. When you take a 3x out from 3x squared, you get x. And taking 3x out from itself leaves -1. Plus, here my GCF is 2. And when I divided 2 out from both those terms, I get x minus 1. Check your work. Yep, I have the same parentheses, so let's proceed. All right, I have two terms, and they both share the common parenthesis of x minus 1. So let's pull x minus 1 out from here, leaving 3x. Let's pull out x minus 1 from here, leaving the plus 2. Final inspection, neither one of these binomials can be factored further, so we're finished. Hopefully by now you have the hang of it, and so if I were you, I'd shut off the video and I would attempt to do number 6 on my own and then come back and check your work. All right, GCF, nope, don't have one, so let's jump into factor by grouping. Quick comment, you could have factored by grouping up here on number 2. It just would have taken a little bit longer than actually just going to the answer here. When the coefficient is 1, you really don't need to factor by grouping. You can just do your factor sum chart, slipping in the two factors here at the ends of the binomials. But you can. Factor by grouping will work for that too. All right, let me list the factors of 18. I think that's it. I need one of them to be, one of the factors in each set to be negative, but the sum to be 7. So I think if I make the smaller number of 2 negative and sum these, I would get that positive 7. Yep. So I'm going to put the minus term up first, plus 9x, and then minus 3. Remember, these two collect to 7x. Now, had both of these factors had to have been negative, then if this term right here is negative, and I put a parenthesis in my next step around these last two terms, I'd have to adjust to make this subtraction of 3 positive. Always just double check your factoring, and that'll tell you if you need to make an adjustment. All right, looks like you can pull out a 2x here. That'll leave 3x minus 1. Plus, it looks like we can pull out a 3 here, and that'll leave 3x minus 1. Well, I must have done everything right so far because I have the same parenthesis. And let's pull out that parenthesis, and that'll leave us 2x plus 3. These remaining factors. All right, so hopefully that's a good review of a factor by grouping. Okay, 7, 8, 9, and 10 are all kind of similar. So let's take a look at them because they look pretty complicated. But actually, they're easier than 4, 5, and 6. All right, when we take a look at number 7 and we look at the structure, notice that you have the factor 25, x to the 6, and then you're multiplying with this parenthesis. That's one term. It's just made up of a bunch of different factors. Plus, and then over here, that's just one more term here. So this expression only has 2 terms in it. So what do? We look for the GCF. All right. Well, first of all, let's tackle the numbers, 25 and 6. Well, 25 and 6 don't share any common factors, so now let's move on to this part of the structure of each of the terms. X to the 6th and x to the 5th. Well, both of these terms have at least x to the 5th, so that's going to be part of my GCF. Now look at the parentheses. Okay, each of these terms have at least 4 of these binomial factors. So I'm going to pull out quantity 4 plus 5x to the 4th power, because 4 of them, of these binomials, are present in each of these terms. Now, just for the sake of a visual, I'm going to go to a bracket instead of a parenthesis. So this is my GCF. Now I have to go back and I have to think about pulling this GCF out of each of these terms up here. So let's take and focus on this GCF being pulled out of this term. Well, I see that 25 needs to be present here. Now x to the 5th will pull out of, divide out of x to the 6th, leaving an x. And just check that real quick. Multiply these two and you're going to get 25x to the 6th. So we're good. Now let's focus on dividing out this factor from this parenthesis. When you divide this factor out from this factor also, that's just a 1. So we're ready to move across the plus sign. Now let's focus on taking this GCF out of this group. Well, we still need a 6. X to the 5th divides out of itself, so I don't need to put an x down here. Now this parenthesis, there's 4 of them that I can take out of 5, so that would leave me to multiply the 6 times 1 more of 4 plus 5x. Okay, remember, our objective is to factor completely. All right, well, we've got a factor here, we've got a factor here. Let's do a little cleanup inside here. I'm going to go ahead and convert back to a parenthesis. So I've got 25x, and then I'm going to distribute the 6 in, plus 24 plus 30x. Well, it looks like I can collect some x's here, so let me just rewrite this. So I'll have 55 x's plus 24. There's nothing more I can do here. There's not a common factor that I could pull out, so I have put my answer in completely factored form. If you study this answer right here, this is one term. It's just made up of a bunch of different factors. This is one big ugly term. But we've completely factored from here to here. Let's take a look at 8. Step back and take a moment and look at the structure. So you've got a term here and you've got a term here. You only have 2 terms in that problem. Well, 5x and 3 don't share any common factors, but I do see that common parenthesis. So I'm going to take that x plus 6, keeping it in parentheses, and then either parentheses or bracket, doesn't matter. When I divide out an x plus 6 from this first term, I'm left with just the 5x. When I divide an x plus 6 out of this second term, I'm just left with the minus 3. We're actually finished. That's actually just one small step of these factor by grouping problems that we did. Then when we got down to the end here, that's all that is. Okay, let's look at number 9. Okay, study the structure. Here's a term, minus, and here's a term. This term is made up of a couple different factors, 2x in this parenthesis. This term is made up of a couple different factors. Let's find the GCF. 2 and 3 don't share a common factor, but x and x squared share an x factor. Haha. X minus 4 to the 3rd and x minus 4 squared. Well, I can pull out at least 2 of those quantities, square of them, 2 of them, sorry. I'm going to go to a bracket because sometimes it just helps me visualize it better. All right, let's take this GCF and pull it out of this first term. Well, I still need a 2. X comes out of itself. I have 2 of these quantities to be pulled out of 3, so I'm left with 1 of them right here. Be sure to put it in parentheses. Minus, well, x is going to pull out of 3x squared, leaving 3x, and x minus 4 squared pulls out of itself, leaving 1. Let's clean this up in here. I'll go ahead and convert back to a parenthesis. So I'm going to have 2x minus 8 minus 3x. All right, so that's going to be negative x minus 8. I would say that it's completely factored, but not really, not technically, it's not completely factored. Look at this binomial right here. We really should pull out a -1, making both these terms positive. But what do we do with that -1 when we pull it out? Well, we kind of move it all the way to the front. That -1 factor really should be placed right up front. So think of this as being a -1 up front times x minus 4 squared. But when you divide it out a -1, you're left with x plus 8. And it just looks better. Is this wrong? No. But to really completely finish it, you should take that -1 factor out of both these terms and put it up front. And I only do that because both these terms are negative. Had that been an x minus 8, I would have walked away at this step right here. Okay. All right, one last one to factor. See if you can do it. Turn off the video and then come back and check your work. All right, we have two factors. 24 and 8 share a common factor of 8. X cubed and x squared share a factor of x squared. And I have at least 4 parentheses of 2 minus 3x in each of the two terms. All right, let's take this GCF out of this first term. 8 goes into 24 3 times. X squared pulls out of x cubed, leaving an x. So it looks like this is going to be 3x to multiply and get me back to this. And then it looks like I can pull out all but one of these binomials. So it looks like I'll have one left. And then plus. Now, pulling this GCF out of this term, you might notice that they're identical. So I do need a 1 here. Think about multiplying back in to see if you get back to the original problem. Let me distribute the 3x in. So that's 6x minus 9x squared. And then I still have that pesky little 1 hanging on. I would say you're finished. You could box this. However, if you checked your solution, they probably would put this in descending order for the variable x, meaning they would have put the quadratic term up front. Okay, and then what, plus 1? Yeah. I would probably want to make sure that this trinomial doesn't factor like I did previous, like factor by grouping. And here's how you know if that trinomial will factor or not. There's not a GCF, but let's go to your factor sum chart and you'll see what happens. We're looking for factors of -9 that sum to 6. Well, the factors of 9 are 1 and 9 and 3 and 3. But within either of these two sets of factors, you can only make one of these numbers negative. And when you sum, you're never going to get 6. So if we cannot complete this factor sum chart, that tells us that that factor, that trinomial factor, it's prime. It doesn't factor. So we are actually finished here. But it did deserve some inspection over here to see if it did factor or not. Okay. Well, I just felt it was good that we went back and we did some more factoring. I don't think you can ever have enough practice with factoring with algebra and then pre-cal and then, of course, on to calculus. Okay, we've got 4 more problems here. Let's see if I can finish those in 7 or 8 minutes. So for these 4 problems right down here, if you haven't already been working on notebook paper, you might want to get some notebook paper now, and then we can work on these. Okay, well, we're not factoring, we're simplifying complex fractions. Now, complex fractions, that word complex means that you have a fraction inside of a fraction. Well, we have a couple of fractions within a fraction. We have fractions in the numerator and then a big outside fraction. Okay, so how do we get rid of fractions in fractions? And that's what we're really asked to do, is simplify so we don't have this complex situation. We just want one fraction. This is too much right here. So for us, what we're going to do, there's 2 strategies, and I prefer one, but I'm going to show you both. All right, so for one strategy, students might say, well, okay, let's get a common denominator in the numerator, and their attention focuses up there. So to get a common denominator with the numerator, you would have to multiply this fraction by x over x, and this fraction over here by x plus h over x plus h. Fine, good. Let's come over here. Let's leave our denominator as h. Now, let's multiply these two fractions together. So we're going to get 9x over x times quantity x plus h. Make sure you put this in parentheses here. Minus, and then over here when we multiply, we have minus 9 times quantity x plus h over that same common denominator, x times x plus h. All right, so I'm going to put the h down here. I'm going to rewrite the numerator with that common denominator. So now I'm going to take the 9x, but now I have to distribute that other negative 9 in, so minus 9x and then minus 9h. Okay, continuing, you might say, hey, we can cancel those. You're absolutely right. So then we're left with negative 9h over x times x plus h. Don't distribute that x in because we really want to try and simplify further. And then I have this over h. Okay, well, think about this h being here, down here being made into a fraction, like h over 1. So then I would say, okay, let's multiply by the reciprocal. Keep the numerator, but change the fraction bar to multiplication and multiply by the reciprocal 1 over h. You might have learned that as keep, change, flip. Keep the numerator, change the division to multiplication, and flip the denominator. But we really mathematically should say multiply by the reciprocal. All right? Well, hopefully you see that these h's across here are going to divide out into 1s, and I'm left with negative 9 over x times quantity x plus h. Did we accomplish getting rid of the complex fraction? Yeah, we did. Is it any prettier? Not really, but that is our answer. If you're comfortable with this, stop the video, attempt this problem, and come back and see how you did. Okay, same strategy for 1 and 2, and then I'll change to another one for 3 and 4. Some students might say, well, let's get a common denominator on top. Okay, that's fine. This would be x plus h over here and x plus h over here. We'd multiply this fraction by x over x. So let's multiply these two together. I'm going to tackle the denominators being multiplied. So that'd be x times x plus h. So I have to multiply and distribute that 3 in, and I'll go ahead and do that on top. I'm going to distribute 3 in and get 3x plus 3h. Then I'm at the minus sign. Let's multiply these together. Then I'm going to have minus 3x over that same common denominator. Okay, let's rewrite the numerator with just one fraction now. So it looks like we're going to have 3x plus 3h minus 3x over x times x plus h. Maybe you see that you can cancel out those 3 x's. So I'll kind of clean this up a little bit. So I'll have 3h over x times x plus h all over h. We're going to come down here and we're going to keep, change, flip. We're going to keep the numerator. And we're going to multiply by the reciprocal of h, which when made a fraction becomes 1 over h. Hopefully you notice the h's will divide out into a 1, and we're left with 3 over quantity x times x plus h. So it started out as a complex fraction, but now it's just a fraction. Oh, sorry about that. Okay, let's look at 3 and 4. Now, if you want to continue to do 3 and 4 the way I just did, fine. I'm going to show you another strategy in simplifying these complex fractions. There's unfortunately always a lot of different ways to simplify things, and it can get confusing, and that's so understandable. But sometimes it's good to know different methods. Okay, well, let's take a look at this complex fraction. Now, what I'm going to do is I'm actually going to look at making every term in this complex fraction. I'm going to make even the h a fraction by putting it over 1. What I do with this strategy is I just look at all the denominators, which that just happens to be 1, and I think about, okay, let me make a common denominator. That would mean that I would multiply x times x plus h. You might be thinking, well, that's nothing new. Well, what I'm going to do is I'm going to come over here and I'm going to multiply this whole numerator by the common denominator that I got from multiplying all these different denominators together, which is this. And I'm going to put this common denominator over 1 because down here in the denominator, I'm also going to put that same common denominator, I'll put it over 1, to multiply into the denominator. So just think of this as being a clever form of 1 here. I can do that. I just made this clever form of 1, a fraction here and a fraction here. So now, let's focus on multiplying into the numerator, into the denominator. I'm going to tackle the denominator first. So when I multiply h over 1 times x plus h over 1, I really don't even need these 1s. I'm going to multiply h times x times parentheses x plus h. So that's just going to be xh times parentheses x plus h. It's kind of common practice to put the h here. It wouldn't be wrong if you did hx times that parenthesis. Okay, now let's focus on the numerator. Let's take this fraction and multiply it into this first fraction here. So kind of ignore this fraction. Oops, should be pulling that up for you guys, sorry. Okay, let's multiply these two fractions together. Before we multiply, notice that x plus h could divide out with that x plus h, leaving the numerator here, x, and that numerator here, 4 to be multiplied. So that becomes 4x minus, I'm at this minus sign. Now let's multiply these two fractions together. Before you multiply, notice that you could divide out this x, and you're going to be left with 4 times that remaining factor of x plus h. So I already got rid of the complex fraction situation, but I do have a little cleanup in the numerator. Let's distribute that negative 4. So minus 4x minus 4h all over xh, x plus h. Notice that these terms cancel, and I'm left with negative 4h over xh, quantity x plus h. Well, everything's in completely factored form, so I can divide out these h's into 1s, and I'm left with negative 4 on top, and then x times x plus h. So no matter what strategy, as long as we're using it correctly, we should end up with the same answer. All right, one more. All right, so what was my second strategy? Well, notice this denominator. Notice that h's denominator is 1. Find the common denominator, the least common denominator. Well, that would be x times parentheses x plus h. And that one doesn't matter. Put that over 1. And then x times x plus h over 1. I'm going to tackle the denominator first, so these 1s don't matter, and I'll end up with the same thing I had previous, xh times x plus h. All right, now be careful on the numerator. We're going to multiply this fraction into this first term and this fraction into that second term right there. So let me cover this up. If you're multiplying these two fractions, the x's will divide out, leaving x plus h to be multiplied by the remaining 1 up here. So I'll start this numerator with x plus h. Now it's time to multiply these two fractions together. Well, the x plus h will cancel with that x plus h. Think of that as a group. Those will cancel, leaving minus x. You might notice that the x's will now cancel. So I'm left with h over xh, x plus h. Hopefully you notice that the h's divide out now because everything's in completely factored form. So I'm left with 1 on top and then x times parentheses x plus h. So I would just say it's probably a personal preference about what strategy you like. The first strategy that I did with the first two problems, getting a common denominator with just the numerator and then multiplying by the reciprocal, or the second strategy in 3 and 4 in multiplying by the common denominator of all the terms in the problem. So it's just up to you. One's not more right than the other. Okay, it's just a different approach.